Today we will discuss about uh, 9.1 FSC Part 1. So we are going to share a series of lectures for mathematics of first year Punjab textbook course. So today we will discuss about 9.1 and what are important things to remember here. We can write it as about angle. If we show an angle by theta, so there are three units of angle. First one is radian, second one is degree, and third one is revolution. So here in 9.1 we will discuss about radian and degree. So what is simple explanation or sign to identify an angle? Is it radian or degree? If it is written in form of pi, so you can say it as radian. And simply if there is this sign, then you say that this angle will be uh, degree. So how to convert? First question is how to convert degree into radian, and our second question will be how to convert a radian into degree. If we simply uh, take it as on whiteboard, this is simply what is procedure to convert radian and what is procedure to convert degree into radian. So if we write as if our question is 30 degree and we want to convert 30 degree into radian, so what will be equal to 30 degree value? And if we want to convert pi over 6, this is radian form and this is degree form. And if I want to convert degree into radian, so simply what is procedure? 30 will be multiplied by pi over 180. So 0 will be cancelled out with 0. 3 ones are 3, 3 6 are 18. So 30 degree will be equal to pi over 6 radian. This is our answer in radian. Similarly, if I want to convert pi over 6 into degree, so what is procedure? There is pi over 180 and there will be equal to pi over 6 will be multiplied by 180 by pi. So 180 by pi, and this will be converted into degree. So pi will be cancelled out with pi. 6 ones are 6, 6 threes are 18. So this will be equal to 30 degree. So simple, this is procedure to convert a radian into degree and degree into radian. So this is formula to convert degree into radian. This is formula to convert radian into degree. This is simple formula. Okay, if we come to our questions, so procedure will be simple. This is exercise 9.1 of this exercise. So this is revision class, so we will go forward by simply doing some of these questions. So this is 30 degree. we know the procedure to convert a degree into radian. So we will convert into radian by multiplying pi over 180. So this will be our final answer. Similarly, if there is 45 degrees, so we know the procedure to convert a degree into radian. So we will multiply it by pi over 180. So this will be equal to pi over 4 radian. Similarly, if there is uh, 10 degree and 15 minutes. This is 75 degrees, 6 minutes and 30 seconds. So to convert it, this we will write it as this will be equal to we can write it by another method. We know that if we use whiteboard, so this will be clear to us. We know that 1 degree is equal to 60 minutes. This is sign for minute, and we know that 1 minute is equal to 60 uh, seconds. This is procedure. If 1 minute is equal to 60 seconds, then 1 degree will be equal to 1 degree will be equal to 60 multiply, if we want to convert a degree into seconds, so 60 multiply 60 seconds, so this will be equal to 3600 seconds. So 1 degree will be equal to 3600 seconds. So this is procedure to convert. If we are given a question 10 degree and 15 15 10, 10 degree and 15 minutes, so we will write as 10 plus 15 over 15 by 60. This will be equal to degree, so this will be equal to 15 ones are 15 fours are 60, so this will be equal to 41 after LCM, 41 over 4. This is degree. So to convert degree, we will multiply it by pi over. This is degree, so we will convert into a radian. So multiply pi by 180. So this will be our final answer. Multiply 40 by pi and 4 by 180. This will be final answer of our previous question. So similarly, if there is 75 degree, 6 minutes and 30 seconds, so we simply can write it as 75 plus 6 over 60 plus 30 over, no, this is 30 seconds. To convert second into degree, we will divide it by 3600. This will be our degree. So after simplification, this answer will be multiplied by pi over 180. So this will be our final answer. So this is question 1. Similarly, if we are going to discuss about question number 2, convert the following. Now there is a second procedure how we will convert radian into degrees. So simply multiply it by 180 over pi. So if we multiply it by 180 over pi, so this will be our final answer, 22.5 degree. Similarly, if there is 13 over 16 pi, So we want to convert it in to degree. So we will multiply it by 180 over pi. Or simply there is another procedure which is discussed here in this book, pi. So if pi will be cancelled out by pi, after simplifying this, our final answer will be equal to 146.25. Another procedure is that we can write the value of pi, which is 180. Pi radian is equal to 180 degree. So if we write the value of pi, then which is 180, so our final answer will be 146.25. So this was the procedure to discuss about question number 2. After question number 2, if we will discuss about question number 3. What is the circular measure of the angle between the heads of the watch at 4 o'clock? Now here we had to tell about the angle. If we look at the watch, the time is 4 o'clock. So what is angle here in these two heads? So since the total angle of the watch, if we convert into x-axis and y-axis, this angle will be equal to 90, this will be equal to 90, 90 and 90. Total angle will be equal to 360. Okay, total angle is 360. Now we want to calculate this angle. So simply we will convert 360 degree will be equal to, if we convert this degree into radian, so this will be equal to pi, 2 pi. So we want these are total 1, 2, 3, 4, 5, 6, 7, 8, 9, 12 parts. So we will divide this whole angle into 12 parts. This will be equal to pi over 6. This is angle between two dots. So if we count, these are 1, 2, 3, 4. This angle between one dot is 5 or 6. The angle between four dots will be equal to multiplied by pi. So this will be equal to, we will multiply it by 4. This will be equal to 2 pi over 3. This is angle at 4 o'clock. Similarly, in our ECAT test, engineering admission test, we are given at 4 o'clock, 5 o'clock. So similarly, we can convert into degree or radian for any kind of angle. So our answer is 2 pi over 3. Similarly, we had to remember about the formula for question number 4, 5 and 6. The formula is L is equal to R theta. If we write L is equal to R theta, and remember theta is radian. Theta will be always into a radian angle. So our question will be equal to find L. If we want to find L, so this will be equal to L is equal to R theta. Similarly, if we want to find R, so R will be equal to L over theta. Similarly, if we want to find theta, so theta will be equal to L over R. So this is our procedure to discuss about these questions. So this is question number 4. Find theta. We know that L is equal to R theta. So theta will be equal to L over simply put the value of L and the value of R to find the value of theta. This is our L, this is our R. The value of L is 1.5 centimeter and value of R is 2.5 centimeter. So after putting this value into the formula, our value will be theta will be equal to L over R. So after putting the value, our final answer will be equal to 0.63. And similarly, question number 2. And if we want to discuss about question number 5, here value, we have to find the value of L. We know that L is equal to R theta. So value of theta is given in pi radian and value of R is equal to 6. So we will apply formula L is equal to R theta. So this will be equal to 6 pi. In the second question, theta is not given in the radian, so we will convert first theta into radian. So how to convert this into radian? Simply after applying the procedure of the simple procedure is that this is 65 degree and this is 20 minutes. So we will write it as we can calculate on our calculator simply. If we use calculator, this is our calculator, and if we want to find the value of okay, now we will convert this 65. We will write 65 plus 20 over 60 will be multiplied by, if we are going to convert this degree into radian, so we will multiply it by pi over 180. So this will be answer, final answer of theta. So theta is equal to 1.1403 and R is equal to 18. So we will apply formula L is equal to R theta. Our final answer will be equal to 20.554. After this, we will discuss about question number 6. In question number 6, we have to find R. So R is equal to, we know the formula L is equal to R theta. So R will be equal to L over theta. So a value of L is equal to 5 centimeter, value of theta is equal to 0.5 or 1 over 2 radian. So we will simply apply the formula and our final answer will be equal to 10 centimeters. After this, if we discuss about question number 7, what is the length of arc? This is called arc and this is called line. We can write it as this is line and this is our line segment. What is the length of arc intercepted on a circle of radius? So value of r is equal to 14 centimeter. R is equal to 14 centimeter by the arm of the central angle of the 45. So theta is equal to 45 degree. To convert degree into radian, we will multiply it by over 180. So this will be equal to pi over 4. Value of theta is equal to pi over 4. Value of r is equal to 14 centimeter. We want to find the length of r means L, value of L. So we will know the formula L is equal to r theta. Simply we will apply the formula L is equal to r theta to calculate the value of L. So r is equal to 14 centimeter, theta is equal to pi over 4. So after multiplication and division, we will be reach at our final answer. So after question number 7, we will discuss about question number 8. Find the radius, means we have to find the value of r. Value of r will be equal to what? In which the arm of the central angle of the measure 1 radian. Theta is equal to 1 radian. Cut off an arc of the length 35 centimeter. Find the radius of the circle. We have to find the radius of this circle in which the arm of the central angle of the measure 1 radian. This is 1 radian. Cut off an arc of the length 30 centimeter. If we cut an arc of 35 centimeters, so after this will be equal to value of L. So R will be equal to L over theta. After putting the value, our final answer will be equal to radius will be equal to 35 centimeter. Question number 9. A railway train is running on a circular track of the radius 500 meters. So value of R is equal to 500 meters at the rate of 30 kilometers per hour. R value of R is equal to 500 centimeter and the speed is 30 kilometers per hour. If we want to convert 30 kilometers into meter, so this will be equal to multiplied by 100. This is per hour. If we want to convert R into second, so we will multiply it by divide by 3600. So after converting, this will be equal to 25 over 3. Through what angle will it turn in 10 seconds? So this is our time. T is equal to 10 seconds. So R is equal to 500, speed is equal to 25 over 3. The distance will be equal to value of L. We have to find the angle theta. Okay, so we know that this is our speed. S, we know that S is equal to V T. We can write it as L is equal to V T. V is equal to 25 over 3 and T is equal to 10. So our L or S will be equal to 25 over 3 multiplied by 10. This will be equal to 250 over 3. So the value of L is 250 over 3, value of R is equal to 500. So to find the value of angle, we will simply write L is equal to R theta. So this will be equal to 250 over 3 will be equal to 1 over 6 radian. So a train is running on a circular track of radius. This is radius at a rate of 30 kilometers per hour. The train is covering 30 kilometer in an hour. We can write it as train is covering 25 or 3 meter in 1 second. So in 10 seconds this will convert, this will cover 25 or 3 multiply 10. In 1 second this is distance, in 10 seconds this is distance covered. So we will simply write as 250 or 3 multiplied by 10. After calculation our answer will be equal to 1 over 6. Okay, question number 10. A horse is tethered to peg by a rope of 9 meters length and it can move in a circle with the peg as center. So we will discuss it in our second part of lesson. Okay, our question number 10 is a horse is tethered to a peg by a rope of 9 meters. So this is circular track and a horse is running and it is tethered to a rope. What is it? This is the center. There is a pillar or you can say there is a stick. With that a horse is tethered. So the length is 9 meters. We can write it as radius of that circular track. So radius is equal to 9 meter and it can move in a circle with the peg as center. If the horse moving along the circumference of the circle, horse is running in the circular track. Keeping the rope tight, how far will it have gone with the when the rope has turned through an angle of 70? Theta is equal to 70. We will convert 70 into pi into radian. To convert radian, we had discussed, we will multiply it by pi over 180. So we have to find the value of L. The horse is tethered to a peg by a rope of 9 meters length and it can move in a circle with the peg as center. If the horse moving along the circumference of the circle keeping the rope tight, how far will it have gone? We had to calculate or evaluate the value of an L, means how far distance it had covered in this part. So we will simply know that about L is equal to R theta, value of R is equal to 9, value of theta is equal to 5 over 18, 7 pi over 18. So this will be equal to final answer. In this part, the horse covered 11 meter. Thus the horse will cover 11 meter distance. This is our simple question. After that, we will discuss about question number 11. The pendulum of these are application of S is equal to R theta or L is equal to R theta formula or application of radian and degree. The pendulum of a clock is 20 centimeter long. This is length of pendulum. If we uh, complete this figure, this will be equal to this circular die. This will be equal to center. So this length will be equal to radius or this length. So our value of r, the pendulum of the clock is 20 centimeters long. This is r is 20 centimeters long meter, and it spins through an angle of 20 degree. So we will simply convert degree into the radians. We have to find this length. If we write it as this length will be equal to L. So L is equal to r theta. So we will simply apply the formula. L is equal to r theta. Value of r is equal to 20 and value of theta is equal to 20 degrees. So we will convert degree into radian. So 20 multiplied by 1, it will be equal to 5/9 radian. Okay. Assuming the average distance of the Earth from the Sun to be 148 multiplied 10 raised to the power 6 kilometer. Assuming the average distance of Earth from the Sun. This is Sun and this is Earth. So this will be our circular track. So distance from Earth to Sun, this will be equal to R, and an angle subtended by means simply a person is standing here and he is looking at this point, and subtended by the sun as the eye of a person on the earth. This there is a person. Uh, this is the angle by the eye of this person. At the eye of the person on the earth of the measure 9.3 multiplied by 10 raised to the power minus 3 radian. This is angle which is 9.3 10 raised to the power minus 3. Find the diameter of the sun. This is application of radian and degree angle. So we had to find the diameter. This is called diameter. This is called chord. A line that meets two parts of the circle is called chord, which is not passing through the center. A line which meets two points of the circle and passing through the center is called the diameter. So we had to find this length from this point to this point. Okay, so value of r is equal to 148 multiplied by 10 raised to the power of 6, and theta is equal to 9.3 10 raised to the power minus 3 radian. So L will be equal to r theta. So after simplification, our answer will be equal to 1.3 multiplied by 10 raised to the power 6. So we had simply applied the formula. L is equal to r theta. So assuming the average distance of the earth from the sun to be, simply remember that this L is not straight line. This is arc. Simply, if we learn this, so we can apply on every question. We can guess that this will be not equal to value of r. Although this is distance, but this is a straight distance. So straight distance will be equal to r, and this kind of distance will be equal to this distance will be equal to. No, this is approximation. This is not exact answer, because exact value will be equal to if we raise Exact value of diameter is this, but L is not a straight line. L is a chord. So there will be small difference in the length of these two lines. This is line, but this is chord. So this is our approximation. We can also write it as approximation. So this is our question number 12. After question number 12, we will discuss about question number 13. A circular wire of the radius 6 centimeter, value of r is equal to 6 cm. A circular wire of the radius, this is the radius of the wire, this is 6 centimeter, is cut straightened and then bent as to lie along the circumference of a hoop of radius 20 centimeter. Now there is a hoop and radius of that hoop is 24 centimeter. So value of r will be equal to 24 because we are calculating for hoop, not for circular wire. Find the measure of the angle which is subtended at the center of the hoop. So you have to find the value of angle. So a circular wire of the radius 6 centimeter. The radius of the wire is 6 centimeter. Is cut straight to as lie along the circumference of the hoop of the radius 24 centimeter. Find the measure of the. This is radius of the hoop, which is 24 centimeter. This is angle we have to find. So length of wire will be equal to circumference of circle. So this is radius. From radius, if we want to find the length of wire, because this is circular wire, this type of wire, we are given with the radius, which is 6. So to calculate the length of this whole wire, we will it multiplied by 2 pi. We will apply formula of circumference which is equal to 2 pi r. So r is equal to 6. So 6 to the 12 pi. So length of the wire is 12 pi. This is length of the wire. This L is not straight length. This is circular wire. This is 12 pi. R is equal to 24. So theta is equal to L over R. We know about the formula theta will be equal to find the measure of the angle which is subtended at the center of the hoop. This is simple calculation. So that the area of the sector of the circular region of radius R is equal to 1 over 2. This is formula to calculate area of the sector of a circular region. So we have to show the about this formula. Simply we will make a circular diagram. This is radius, this is also radius, this is theta, this is value of L. So we know that area of sector over, this is formula, area of sector over area of circle is equal to central angle of the sector over angle of circle. Area of sector over area of circle is equal to central angle of the sector, this angle, and total angle. Total angle is 2 pi. Area of circle pi r square. Area of sector and triangle angle is theta. So simply if we calculate, we want to calculate area of the sector. So we know that area of the circle is pi r square, and area angle of sector is pi, and angle of the circle is 2 pi. So this 2 pi will be multiplied by pi over 2 pi. So this will be equal to 1 over 2 r square theta. So simply we have to learn about the simple formula, which is area of the sector over area of the circle will be equal to central angle of the sector or central angle of the circle, which is equal to 2 pi. Okay, 3 questions are remaining behind. two cities A and B. This is we can simply take two cities. Two cities A and B lie on the equator. This is our equator. If we make the diagram of Earth, this is called equator. And similarly, this is called equator, and this is called upper. This is sorry, this this is called Tropic of Cancer, and this is called Tropic of Capricorn. So if we look at countries which are on equator, we can say that the countries which are on equator are very highly beneficial in every kind of aspects like seasons, water, and other things. Countries on equator are, we can say that Indonesia, Somalia, Kenya, uh, Uganda, Colombia, Brazil. These are some countries which are on situated on equator. So our simple question: two cities A and B lie on equator. This is equator, and two cities like A and B are on equator. Such that their longitudes are 45. There are two lengths. This is equator. Uh, uh, there are longitudes and latitudes. Longitudes are 45 east and 25 west. 45 east and 25 west respectively. Find the distance between the two cities taking the radius of Earth as 64. R is equal to 64 kilometers. We know that. Theta is equal to 45 plus 25 will be equal to 70. We have to find distance. It means this distance we have to find simply. This will be equal to L. We have to find value of L. R is equal to 6400 kilometers, and theta is equal to 25 plus 45, because we have to calculate this total distance. We can also calculate distance separately. So distance 1 and distance 2. After calculation we will add. So other method is simply add these, and 25 plus 45 will be equal to 70. 70 will be converted into radians. This will be equal to 7 over 18 pi. So L is equal to R theta. So value of R is 4 and theta is equal to 7 over 18 pi. So this is our final answer. Distance between two cities will be equal to 7819.075 kilometers. Now, second last question is 16. Simple question, as we have discussed earlier, the moon is obtained at angle 0.5 degree. We will convert 0.5 into the radian. At the eye of an observer on the Earth, this is on Earth, this will be the arc. So taking the radius of Earth is 64. We have to find the value of L. L is equal to R theta. This is simple question. So our last question is the angle Okay, this is our last question. Question number 17. The angle obtained by the Earth at the eye of a specimen landed on the moon. This is our moon. This is angle. This is L. This is R. We know about in our previous diagram. So theta is equal to 1 degree, 54 minutes. So this will be equal to 0.03316 radian. R is equal to 64 kilometers. Find the approximate distance between the moon and the Earth. We had to find the approximate distance between the moon and Earth. Means we have to find this distance from this is moon, this is Earth. So what will be the value of L? Value of the radius of the Earth is 6400 kilometers. Find the approximate distance between the moon and Earth. So this is our angle value. L will be equal to L is equal to 2R. Means we can write as L is diameter. If we write diameter of this is diameter, this is radius. So we know that D is equal to our diameter here is L. We know that the diameter will is a double of radius, means this radius 1 and 2. If we meet them, then this will be equal to our diameter. So L is equal to 2R, 2, and R is equal to 6400 kilometers. So this will be equal to L is equal to double of the radius because L is diameter. So we will simply apply the formula. L is equal to R theta to calculate the final answer of this question. So this was our whole exercise 9.1 we have discussed here today.